So we're going to finish this up, and I'm going to show you how easy it is to go back and forth between whatever units we want to talk about now that we understand how to go to moles of something. And you'll see the moles pretty useful. So I'm going to go back to this map. And before I do that, we're going to just read one more time what we were doing a little bit ago. We said, how many water molecules in a 64.7 gram cup of water? And I'm going to show you one more time the mole map. And this is in Canvas. And you can always refer back to the video. And you could use any mole map you want. They all look pretty similar. I like mine because it has all of the conversion factors for you. You don't have to go trying to remember what they are. We're going to work on all that stuff as we move along. So we want to go from grams of water to how many molecules of water. And in the last video we just did from grams to moles. That's how we ended up with 64.7 grams ended up being 3.59 moles. Now I'm going to take that 3.59 moles, I'm going to go this way to get to how many water molecules is that. And I'm going to use this conversion factor right here that I'm circling around because the arrow is pointing that way. It's very simple. Check this out. We go 3.59 mole, because that's what we're given. And put that over 1. Hopefully you remember that any number over 1 is just the same number. And I'm going to multiply it by that conversion factor, which is 6.02 times 10 to the 23rd particles over 1 mole. 6.02 times 10 to the 23rd particles over 1 mole. And it's not as crazy as you think. This part here, the times 10 to the 23rd particles, we're going to hang on to that. So you could use your calculator to do all this. You might even have a fancy scientific calculator that'll let you put in the times 10 to the 23rd power and take care of all that for you. But this is not difficult when we're just doing something as simple as multiplying this straight across and this straight across. So step 1, now that I've written everything out the way it's supposed to be, I'm going to go ahead and get rid of my mole units because I got one on the top and one on the bottom. And then I'm just going to multiply these two numbers, this one and this one. See, they just multiply straight across. And my calculator tells me, let's do that real quick, sorry for the delay, 3.59 times 6.02, 21.61. So I know that I have 21.61, but that's not everything. I told you the 10 to the 23rd is something we're going to add on later. I like to mentally draw a box around it like this and say to myself, okay, I'm going to put that in the box while I do this stuff here. And then once I have that answer, the 21.61, then I'm going to take this back out of the box and put it on the end. And it just works like this. It's not difficult at all. That's it. That is my answer. In a 64.7 gram cup of water, there are 21.61 times 10 to the 23rd molecules. Particle is the same, especially on our map. Representative particles, molecules. Particle, molecules. Easy enough, right? 21.61 times 10 to the 23rd particles. That is an enormous amount of particles. Again, just this number here, the 6.02 times 10 to the 23rd, if you were here watching the crazy jelly bean guy video with us, you would know that if we had 1 mole of jelly beans, that would equal this number of jelly beans. And this number of jelly beans is big enough to fill the entire world with jelly beans, from the center of the core of the Earth all the way out to the surface, and then cover the entire surface. That's how many jelly beans that would be. It's ridiculous. Okay. Not difficult. One more time. We went from a certain amount of grams right here. We had 64.7 grams of H2O. And we looked at the map and we said, grams are down here. And there's a conversion factor we used. It said 1 mole over molar mass. We said, well, I don't know what the molar mass of water is. But we used our periodic table. We used our periodic table and said, there's the molar mass for a hydrogen. There's the molar mass for an oxygen. We plugged them in right here. And we said, oh, don't forget, we've got 2 hydrogen times 2. We only had 1 oxygen, so we just left it. I told you we could have just rounded those to an easier to work with number. That would be fine. You could do that if you want. That's how down here I ended up with 18 grams. So all I did was 64.7 grams of water times this conversion factor right here, because it's going from here to mole. Molar mass is just that number right there. I multiplied everything straight across, top and bottom, and then I just divided the top by what was left on the bottom. That told me how many moles of water. Very important to know how many moles. Then I took that number of moles and I used it to go from moles to molecules. And I used this conversion factor that points towards the particles or the molecules. There it is right there. There it is over here on the left. Here it is here in use. Remember I said, just put that times 10 to the 23rd in a box and we'll open it up later. So I multiplied this number times that number. Remember, don't forget to cancel out whatever units are on top and bottom together. I multiply straight across on the top, multiply straight across on the bottom. I end up with 21.61, and then I take what's out of the take what's in the box and I pull it out and put it on the end, times 10 to the 23rd. All right.